Welcome to another lesson of Math 1314, College Algebra. Today we will discuss two sections, 2.2 and 2.3, linear equations in one variable, models, and applications of those linear variables. In these sections, our learning objectives will be to solve equations in one variable algebraically, to solve a rational equation, to find a linear equation. Given the equation of two lines, determine if the graphs of those lines are parallel or perpendicular. Write the equation of a line parallel or perpendicular to a given line. And set up linear equations to solve real-world problems and use formulas to solve real-world problems. Let's go ahead and get started. We first need some definitions. A linear equation is an equation of a straight line. It's a linear equation written in one variable. So linear equations in one variable can be written in the form ax plus b equal to 0 and are solved using basic algebraic operations. Now, we need to be able to classify linear equations into one of three types. The first is an identity. The identity equation is true for all values of the variable. A linear equation that is true for all values of the variable. We'll sometimes call this infinitely many solutions. A second case is an inconsistent equation. That's a linear equation with 0 solutions. And then finally, we have a conditional equation for linear equations. Linear equation with only one solution. So there are conditions on the variable that make the equation true. For the linear case, we only have one solution. So to go back to the form of the equation up here, ax plus b equal to 0, that's true where a and b are real numbers and a is not equal to 0. So those are the definitions we need to get started. Let's go and get some properties on how to solve a linear equation in one variable, and then we'll do some examples. So steps for solving a linear equation in one variable. The first thing that we need to do is understand that we can add, subtract, multiply, or divide both sides of an equation and that will give us an equivalent equation that we can manipulate. The only exception is that we cannot divide by 0. The next thing we need to do is apply the distributive property if necessary. Then we isolate the variable on one side of the equation and constants on the other. And finally, when the variable is multiplied by a coefficient, we multiply both sides of the equation by the reciprocal of the coefficient to complete the solving process. And I would always add in a last step to check your answer by substituting back into the original equation that you had. Let's move on and do an example. Okay, we want to solve the equation 2x plus 1 equal to negative 9. Now, is this a linear equation in one variable? Can it be written in the form ax plus b equal to 0? Well, if we added 9 to both sides, we would have 2x plus 10 equal to 0, which is in the form that we need. So it could be, this is a linear equation in one variable. We don't have to do that. We don't have to go through those steps to prove it, but just know that you can. What we need to do to solve it is to do a subtraction of 1 on both sides, which leaves us 2x equal to negative 10. And then what legal step can we do to isolate x? Well, we can divide both sides of the equation by 2. On the left side, the 2's cancel out, and I'm left with x is equal to negative 10 over 2, or negative 5. How would I go back and check that this is correct? Well, I would take the 2 times negative 5 plus 1. Well, that's equal to negative 10 plus 1, or negative 9, which is exactly what we started with. Now notice in this case that we did the adding subtracting, multiplying, and dividing that was necessary to isolate the variable. We didn't have to use the distributive property. We were able to isolate with just that one step, and then we divided by or multiplied by the reciprocal. So dividing by 2 is the same as multiplying by 1/2. So our final answer is x equals -5 is a solution to the equation. Now you may be asked to put this in set notation. If you are, it's a curly brace containing the number -5, and that is your solution set. Let's do another example. What happens if we have -2x times the quantity 3x minus 1 plus x equal to 14 minus x? Notice that we have the variable on both sides of this equation, so we're going to have to move it from one side or the other. So what do we do first? Well, the first thing I want to do is to go ahead and subtract an x from both sides. Now, you don't have to do this first, but that's what I want to do first to get started. So I'm left with -2 times 3x minus 1 is equal to 14 minus 2x. Now, at this point, I can continue to do multiplication, division, addition, subtraction, but I really want to go ahead and do the distributive property and distribute the -2 to both terms on the left side. So -2 times -2 times 3x is -6x. -2 times -1 is plus 2 is equal to 14 minus 2x. Okay, so I want to add the smaller value, the smaller farthest away from on the left value. So I'm going to add 6x to both sides. That leaves me with 2 is equal to 14. -2 plus 6x is plus 4x. Now I can subtract 14 from both sides, and I'm left with -12 is equal to 4x. To isolate that variable, I multiply by the reciprocal, 1/4 on both sides. It's the same thing as dividing by 4. The 4's cancel on one side, and I'm left with x is equal to -12 over 4, which is -3. Now again, we can plug that back in and check it. That's something that you should do on your own to make sure that we've gotten the correct answer, that x equals -3 is a solution to the equation. Okay, let's try another type. So what happens if we have a rational equation? Well, first of all, what is a rational equation? We'll talk about a formal definition here in a moment, but first, let's just assume that an equation is a rational equation if it contains at least one rational expression. In this example, 7 over 2x minus 5 over 3x equal to 22 over 3 has 3 separate rational expressions. So our very first step is to try to clear the denominators. And the way we do that is with the least common denominator. We know that 2x, 3x, and 3 must be factors of this LCD. And so we know that the first multiple that contains all of these is 6x. So what we need to do is we need to multiply 6x on both sides of this equation. So 6x times the quantity 7 over 2x minus 5 over 3x is equal to 22 over 3 times 6x. Our first step is to distribute the 6x to both terms, the first being 6 divided by 2 is 3 times 7. The x's cancel. And then 6x times a negative 5 over 3x. Well, 6 divided by 3 is 2 times 5. And the x's also cancel out in this case. And then on the right-hand side, we have 6x over 3. Well, 6 over 3 is 2. So we have 22 times 2x. So we can simplify both the left and right-hand sides. 7 times 3 is 21, minus 2 times 5 is 10, is equal to 22 times 2x, which is 44x. 21 minus 10 is 11, which is equal to 44x. We can divide both sides by 44 or multiply by 1 over 44. The 44's cancel. I'm left with x is equal to 11 over 44, which reduces to 1 over 4. So x equals 1 over 4 is a solution to the equation. Now notice that we didn't specifically discuss issues with division by 0. We only would have needed that if one of our solutions had happened to be 0. And we'll discuss that in more depth as we move on. Let's consider another example. Let's consider solving another equation. This time we have 2 over 3x is equal to 1/4 minus 1 over 6x. So what do we do first? Well, if we can, we want to factor the denominators. Well, there's not really anything that we can factor specifically here. So what is our LCD? Well, we know we have to have 3x as a factor, 4, and 6x. So it looks like our LCD is 12x. So what we need to do is multiply both sides of the equation by 12x. Okay, so we'll do the multiplication on the left-hand side first. 12 divided by 3 is 4. X divided by x, those cancel, times 2. The numerator in the first ratio. 12x times 1 over 4 is 12 over 4, which is 3x, minus 12x over 6x gives us what? What's 12 over 6? Is that 2? The x's will cancel again. And so we're left with 4 times 2 on the left-hand side, which is 8, is equal to 3x minus 2. We add 2 to both sides, and 8 plus 2 is 10, is equal to 3x. Divide both sides by 3, and x is equal to 10 over 3 is our solution. Let's formalize the definition of a rational equation and how to solve it. The definition of a rational equation is that a rational equation contains at least one rational expression where the variable appears in at least one of the denominators of those rational expressions. So how do we solve a rational equation? Well, we've done a couple of simple examples before, but here's what you do in general for a rational equation. The first thing you do is to factor all of the denominators. Then you find and exclude all values of the variable that would cause a denominator to be 0, and thus causing division by 0. Then you need to find the LCD of the various terms in the equation. Then you multiply both sides of the equation by that LCD that you found. Then you should be able to clear all of the denominators out and solve the remaining equation. And then finally, as always, check your answer. Let's do some more examples with rational equations. Okay, this example is to solve negative 5 over 2x plus 3 over 4x is equal to negative 7 over 4. So our first step is to factor all the denominators. Okay, so that gives us, in the first denominator, 2 times x. The second one is 4 times x, or 2 times 2 times x. And the last one is 4, or 2 times 2. So what factors have to be in our LCD? Well, we'll talk about that in just a moment, but first we need to see what values of our variable will cause the denominator to be 0. Well, in this case, the only thing that will cause the denominator to be 0 is in this 2x, where x is equal to 0, in the 4x, where x is equal to 0, and those are the only places. So we need to, under step 2, exclude the value x equals 0 from consideration. Okay. Step 3, find the LCD. Well, what factors need to be involved? Well, we know we'll need at least 2 factors of 2, so 4, and we'll need at least a factor of x. So 4x should clear all of the denominators. So what we need to do then is we need to multiply both sides of the equation by 4x. Okay, so we'll first distribute the 4x to both terms. So we get 4x over 2x, which is 2 times negative 5. 4x times 3 over 4x gives us just a positive 3, is equal to, the 4's cancel here, and we get negative 7x. On the left-hand side, we have negative 10. 2 times negative 5 plus 3 is equal to negative 7x. And then we can add those together. Negative 10 plus 3 is negative 7, is equal to negative 7x. We divide both sides by negative 7. Negative 7 divided by negative 7 is 1. Negative 7's cancel there, and we're left with x is equal to 1. So x equals 1 is a solution to the equation. And then we can go and check that, but I will leave that to you. That step, what we did here, is step 4. Step 5 was solving the remaining equation, and now we're at this point. Step 6 is to check, and you can do that on your own for homework just to make sure you understand the concept. Let's consider an example that's a little bit more complicated. 2 over x minus 2 plus 1 over x plus 1 equals 1 over x squared minus x minus 2. We want to solve and list excluded values. Okay, so our first step here is to do what? Well, we need to factor all of the denominators. Well, the first denominator is factored. The second denominator is factored. But that last denominator is not. So how do we factor this using what we know? Well, we know that the factors, because the leading coefficient is 1, that we need to look at the factors of -2, that when we add them together, we get a -1. Well, what are the factors of -2? Well, I have 1 and -2 and -1 and 2. Okay? So what is the sum of 1 and -2? Well, that's -1. And what's the sum of -1 and 2? That's +1. So the two values we want to choose are 1 and -2. So the way we can rewrite that, based on what we know about factoring, we can rewrite this denominator as x plus 1 times x minus 2. Okay? So what values must be excluded? What would cause the denominators to be 0? Well, we have an x minus 2 in one term and x plus 1 in one term, and then we have that on the other side of the equation too. So the denominator will be 0 if x plus 1 is equal to 0 or if x minus 2 is equal to 0. Well, we can solve both of these equations. We can subtract 1 from both sides of the first one. X is equal to -1. Or we can add 2 to both sides of the second equation, or if x is equal to 2. Okay, so -1 will cause the denominator to be 0, and so will 2. So we have to exclude those values from consideration. So what's our LCD? Well, our LCD is x plus 1, x minus 2. So we'll multiply that on both sides of the equation so we can solve for x. So x plus 1, x minus 2 times 2 over x minus 2 plus 1 over x plus 1 is equal to x plus 1, x minus 2 times 1 over x plus 1, x minus 2. Well, on the right-hand side, everything will cancel out. The x minus 1s, or the x plus 1s cancel, and the x minus 2s cancel, so I'm just left with 1. And then when we distribute, there's a lot of distributing that needs to happen here. In the first case, this portion will distribute to the first term and will cancel out the x minus 2. So I'll have 2 times x plus 1. And then when I distribute to the second term, the x plus 1s will cancel, and I'll be left with x minus 2 is equal to 1. Then what we can do is we can distribute the 2. 2 times x is 2x. 2 plus 1 is, or 2 times 1 is 2. Plus an x minus a 2 is equal to 1. 2x plus x is 3x, combining like terms. Plus 2 minus 2 is 0. So 3x is equal to the right-hand side, which is 1. Divide both sides by 3. The 3's cancel, and x is equal to 1/3. And that's our final answer. Now we can go back and check, which I will leave for you to do on your own time. Let's now switch gears and talk about finding linear equations if we're given certain amounts of information. Probably one of the most familiar forms of a linear equation is the slope-intercept form. In fact, you've probably seen this before. Linear equations can be written as y is equal to m times x plus b, where m is the slope and b that. And B is the y-intercept of the line. So let's first talk about the slope. The slope of a line. Time for a definition. The slope of a line, denoted with m, represents the change in y over the change in x. For two given points, x subscript 1, y subscript 1, and x subscript 2, y subscript 2, the following formula determines the slope containing both points. And that is the slope m is equal to the difference in the y values, y2 minus y1, divided by the difference in the x values, x2 minus x1. This brings us to the point where if we're given 2 points that we can find the slope of a line, the line that contains those 2 points. Let's do an example. Let's consider the following example. Our instructions are to find the slope of a line that passes through the points -2, 6 and 1, 4. Well, we know that the slope is equal to y2 minus y1 over x2 minus x1. It makes no difference which order we choose the points. We just need to make sure that we're consistent with the x and y. So I'll start with the second point. The y value is 4. And the first point's y value is 6, so 4 minus 6. And then the x value on the second point is 1. And the x value on the first point is -2. Okay, so we have 4 minus 6, which is -2, and 1 minus a -2, or 1 plus 2, which is 3. What this means is that our slope is -2/3, and for every 2 units that I go down in y, I go to the right 3 units in the x direction. So 2 change in the y gives me a 3 change in the x. We'll interpret what this means as we move forward and see some more examples. Let's move on and consider identifying the slope and the y-intercept if we're given a specific equation. Here's another example. Identify the slope and intercept given the equation y is equal to -2/3 x plus 4. What is our slope in this case? Well, remember, the slope-intercept form is y is equal to m times x plus b, where m is the slope and b is the intercept. Well, the slope is the coefficient in front of x, so m is equal to negative 2/3, just like we saw before. What is our y-intercept, or b? Well, that's a positive 4. So that means that the y-intercept, that's the point where the line crosses the y-axis, will happen where y is equal to 4. We can always substitute x equal to 0 to find the y-intercept. But if it's in slope-intercept form, we don't have to do that because we can just see what b is right away. Another useful helping formula in linear equations is the point-slope formula. Let's move on and consider that formula. Well, the point-slope formula says that if we're given one point and the slope, the formula that follows from will give us the equation of a line. So y minus y1, y subscript 1, is equal to m, the slope, times x minus x1. So x1, y1 is a point on the line. So let's try an example where we will be finding the equation of a line given the slope and 1 point. In this example, we want to find the equation of a line given a slope of m equal to 4 going through the point 2, 5. Remember, our formula is y minus y1 is equal to m times x minus x1. So now we substitute the values of our point. So y minus 5 is equal to m is equal to 4, x minus 2, which is x1. Now, if we distribute on the right-hand side, we'll keep the left-hand side the same. 4 times x is 4x. 4 times negative 2 is negative 8. If we add 5 to both sides, we get that y is equal to 4x minus 3. This tells us our slope, which is 4, and our y-intercept, which is negative 3. We were able to put this into slope-intercept form, which is the most easy for us to read the slope and the intercept, which is why it's called the slope-intercept form. Now, can we find the equation of a line if we're given 2 points? Well, let's try an example where we do that. In this example, we're given the points 3, 4, and 0, negative 3, and we are to write the equation of the line containing the points in slope-intercept form. Now, you may be thinking, well, I've been given 2 points. We have the formula for slope, and we have the point-slope formula, but the point-slope formula requires a point and the slope. Well, we can find the slope using 2 points, which we have. Again, that formula is m is equal to y2 minus y1 over x2 minus x1. So we'll choose 4 minus a negative 3 over 3 minus 0, which is 4 plus 3, which is 7 over 3. So our slope is 7/3. And we can choose either point we want to plug into the point slope formula. I'll choose the first. That formula is y minus y1 is equal to m times x minus x1. So y minus 4 is equal to 7/3 x minus 3. Again, we can multiply that out by distributing. Y minus 4 is equal to 7/3 x minus a 7/3 times negative 3 gives us minus 7, because the 3 cancels out. The 3 cancels out. We can add 4 to both sides. Y is equal to 7/3 x. Negative 7 plus 4 is negative 3. And so our final answer is y is equal to 7/3 x minus 3. There's another way that we can represent the equation of a line, and that's called standard form. So the standard form of the equation of a line can be written as follows. AX plus BY is equal to C, where A, B, and C are integers. The x and y terms on one side of the equal sign, and the constant term is on the other side. So again, in standard form, we have the stuff associated with x and the stuff associated with y on one side of the equation, and then the constant on the other side. So how does this differ from slope-intercept? Well, in slope-intercept, we have the y isolated, whereas in the standard form, the x and the y are both on one side of the equation. So can we find the equation of a line and write it in standard form? Well, let's give it a try. Let's find the equation of a line in standard form with slope m equal to negative 1/3 that passes through the point 1 1/3. The first thing we want to do is plug these two pieces of information into the point slope formula, which is y minus y1 equal to m times x minus x1. So let's plug it in. Y minus 1/3 is equal to negative 1/3 x minus 1. Now we can distribute. Y minus 1/3 is equal to negative 1/3 x plus 1/3. Okay, then we can add 1/3 to both sides. We'll come up here, and we have y is equal to negative 1/3 x plus 2/3. Okay, that would be the slope-intercept form, but we've been asked to put this in standard form. So let's add 1/3 x to both sides of the equation, and we get y plus 1/3 x is equal to 2/3. And is that a legal place for us to stop? Technically, yes, it would be if the requirement wasn't for C. Look back to our definition. C has to be an integer. So we can't have just a rational number there. We need an integer. So we need to multiply both sides of the equation by 3 to get rid of that denominator. So what that gives us when we distribute on the left side is 3y plus 3 over 3 is 1, so just x, is equal to 2 times 3 over 3. The 3's cancel and we're left with 2. So our final answer in standard form is 3y plus x is equal to 2. Let's now consider vertical and horizontal lines. So horizontal and vertical lines. Vertical lines can be expressed by a formula x equals c for some constant c. In the case of a vertical line, the slope for those vertical lines is undefined. Now, why does that happen? Why is it undefined? Well, our formula for slope, m equal to y2 minus y1 over x2 minus x1, should give us some clues as to why this would be the case. So if we had a constant value for x, that would mean that it's always the same, which would mean that c minus c is 0, so that would cause division by 0 for any change in x, or for any change in y, because x is constant. On horizontal lines, a similar thing happens, except the constant is in the numerator, where y is equal to some constant. In that case, the slope for horizontal lines is always 0. And the way that you can tell if you're given 2 points on a vertical line or a horizontal line, one of the variables, x or y, will be constant. So if you're given 2 points, say 2, 3, and 2, 4, is that a vertical or horizontal line? Well, it's saying that if my y value is 3 or my y value is 4, then my x value is the same at 2. So if I was to plot that, we would have a constant x and a variable y. This would be a vertical line. What if it was the other way around? What if it was 3, 2, and 4, 2? This time we have a constant in y. That means that the x's can change, but the y's don't. This is a horizontal line. Now, all of our formulas that we've used so far would prove this to us, that these things happen, but we don't have to use those to know. We can have this special case and use these facts when we are looking at horizontal and vertical lines. Another interesting topic that we can consider with linear equations are whether lines are parallel or perpendicular. And we'll discuss what that means in just a moment. Okay, let's consider parallel and perpendicular lines. What does it mean to be parallel or perpendicular? Well, parallel lines are 2 or more lines that are considered to be parallel if they have the same slope and different y-intercepts and never intersect. That's one of the properties. So if we have 2 equations that look like this, y is equal to 3x plus 4, and y is equal to 3x minus 7, are those lines parallel? Well, they clearly have different intercepts, because 4 is not equal to negative 7, and the coefficient in front of x in slope-intercept form is 3 in both cases. So this line and this line these are parallel. What if I have y is equal to 3x plus 4, and I want to find any line that's perpendicular to it? Well, in slope-intercept form, I'll start with y equals. Now the slope in this case, the slope of the first line is 3. What does the slope of the second line have to be for it to cross at a 90-degree angle? Well, the slope of one line, M1, is 3, so M2 has to be the negative reciprocal of that line. So that has to be the negative reciprocal. What does it mean for a reciprocal? Well, that is 3 over 1 in the first case is our slope in rational form. The reciprocal is the flip of that, which is 1/3. So the negative reciprocal is negative 1/3. So what we would need is for that value to be negative 1/3 x plus some other value, let's say 2. Those two lines, we'll zoom out just a hair. These two lines are perpendicular. So again, parallel lines never intersect, and the equations have the same slope. Perpendicular lines do intersect at a 90-degree angle, and the slope of one line is the negative reciprocal of the other. You take the slope of one, you flip it, and put a negative sign in front of it. If it's already negative, you just switch the sign. Okay, so let's do an example of that. If we're given the two lines below, we want to determine whether they are parallel, perpendicular, or neither. So the two lines we have are 2y minus x is equal to 10 and 2y is equal to x plus 4. Now what we want to do is we want to be able to get this into slope-intercept form, y equals mx plus b. So we want to isolate y. The first thing we'll do with the first equation is add x to both sides. So we have 2y is equal to x plus 10. Then we want to divide both sides by 2. And so we're left with y is equal to 1/2 x plus 10 over 2, which is 5. And then in the second equation, we want to go ahead and divide by 2 on both sides. That leaves us with y is equal to 1/2 x plus 4 over 2, which is 2. Now, are these lines parallel, perpendicular, or neither? Well, these are parallel lines because they have the same slope and different y-intercepts. So let's try and graph these. The first one, the first equation we did, which I boxed in purple right here, what do we get for y when we plug in 0 for x? Well, it's the y-intercept, or 5. 0, 1, 2, 3, 4, 5. And then I'm going to choose a relatively easy value for a second point, x equals 2, because 2 divided by 2 is 1. So when x is equal to 2, y is 1 plus 5, or 6. That's roughly where that is. And then I'll take my handy ruler and try and get those as closely lined up as I can. Make the ruler disappear. Continue those arrows infinitely. Let's change colors and do the second equation. Where does it cross the y-axis? Well, when x is 0, y is equal to 2. And again, we'll choose 2 as our point for x, which 1/2 times 2 just gives us 1. 1 plus 2 is 3. So when x is 2, y is equal to 3. Again, we'll get the ruler out. Again, this is not perfectly to scale. Seems like my point was a little bit off when I drew it the first time, but that's okay. That's closer to it. So those are the graphs of those two lines. We just need to choose 2 points so we can draw a line through them. They have the same slope. The second one has a slope of 1/2. The first one has a slope of 1/2. They have intercepts of 5 and 2, which are different. Therefore, we have parallel lines. So if we're given an equation of a line, can we write an equation of a line that's parallel or perpendicular to it? The answer is yes. And there are 3 steps to doing that. The first is to find the slope of the line we're given. And usually the easiest way that we can do that is to rewrite that equation in slope-intercept form, or y equals mx plus b. That way we can see the slope right away. Then we can use the slope that we found and the point we were given in the point-slope formula to be able to create the new equation. Then we can simplify that equation to slope-intercept form, and then we can compare it to the line we were given. So let's try an example where we write the equation of a line parallel to a given line passing through a given point. So here's an example. Find the equation of a line parallel to 5x equals 7 plus y that passes through the point -1, -2. So the first thing we need to do is to find the slope of the given line. The way we do that is to get it into slope-intercept form. So I'll rewrite the equation. And the way I isolate y is to subtract 7 from both sides. And I'm left with y is equal to 5x minus 7. So now we know that our slope of our new line needs to be 5. So in our point-slope formula, y minus y1 is equal to m times x minus x1. I can plug in the slope and then my x1 and my y1. Okay, so we have y minus a -2 is equal to 5 times x minus a -1. Okay, so that gives us y plus 2 is equal to, we'll distribute now, actually I'm going to rewrite one more step, that's x plus 1. So y plus 2 is equal to 5x plus 5. And then I can subtract 2 from both sides, and I get y is equal to 5x plus 3. Now, can we compare that to our original line, which is 5x minus 7? Those have different intercepts. One is -7, one is 3. And the slopes are both 5, so these two lines are parallel, and we found a line that goes through the point -1, -2, and has that slope. Now, if we were given a line that passes through, and we want to find a line that passes through a point that's perpendicular to a given line, can we do that? Well, the answer is yes. Yes, we can. So what we want to do now is we want to find the equation of the line perpendicular to 5x minus 3y plus 4 is equal to 0. that passes through switch to the eraser, negative 4, 1. Well, first we need to find the slope of the original line. That's 5x minus 3y plus 4 equals 0. And we want to solve for y. We'll subtract 4 from both sides. So we get 5x minus 3y is equal to negative 4. Then we need to subtract a 5x from both sides. And we get negative 3y is equal to negative 5x minus 4. Then we divide both sides by negative 3. And we get y is equal to negative 5 over negative 3, or 5/3 x, plus 4/3, because we have negative 4 over negative 3. So that's our equation of the first line, our given line, and our slope is 5/3. So M1 is 5 over 3. What is the slope of our new line, M2? Well, we flip that, so we get 3/5, and we throw a negative sign on it. So now we can use the point slope formula with the point negative 4, 1, and the second slope. Here's our point slope formula. Y minus y1 is equal to m. In this case, it's m2, but we don't have to write that. X minus x1. So we have y minus, what's our y value? A 1 is equal to our m value, which is negative 3/5, x minus a negative 4. So we can simplify what's in the parentheses to leave negative 3/5 x plus 4. And then we can distribute negative 3/5 x plus, well, it's not going to be plus because we have the minus there, minus 4 times 3 is 12 over 5. Okay, and then we need to add 1 to both sides. So we get y is equal to negative 3/5 x. We need to add, so we have 5/5 minus 12/5. 12 minus 5 is 7, so minus 7/5. And so if we've done this all right, we should be able to compare these two lines and see that they are perpendicular to one another. This line has a slope of negative 3/5, and the original line had a slope of 5/3, as you can see back on the first page. And those are all the examples in section 2.2. We'll now move to modeling and doing applications with linear equations. If we want to model real-world problems with linear equations, we need to have a framework for solving those problems. So here are some steps that you can follow to model real-world problems with linear equations. The first thing that you need to do is to identify the things that you know. Identify your known quantities. Once you've done that, you also need to identify what you don't know and assign variables to represent those unknowns. If there are multiple unknowns in step 3, you'll want to try to express one of the variables in terms of the other. Then you'll write an equation interpreting the words from your problem as mathematical operations. And finally, you'll solve the equation and express that solution in clear language using the units of measurement if it's applicable. So now that we have a framework to use, let's try to model a linear equation to solve a problem. Here's an example of modeling a linear equation to solve an unknown number problem. Find a linear equation to solve for the following unknown quantities. One number is 3 more than twice another number. If the sum of the numbers is 36, find the numbers. Well, the first thing we want to do is to identify what we know. Well, the only things that we know are that one number is three more than twice another, okay, and that the sum is 36. So let's assign a variable to represent the unknown. Let x be the first number. We have two different numbers that we need to know, so we want to find a way to write the second unknown one in terms of the first, which we should be able to do. The first number is just x, okay? What is the other number? Well, the other number is 3 more than 2 times the first number. If we add those two numbers together, we get 36. Okay, so what we can do now is we can add those two quantities. We have x plus 2x plus 3 is equal to 36. We don't have to distribute anything there. So we have 3x plus 3 is equal to 36. Now we can subtract 3 from both sides. So we have 3x is equal to 33. Divide both sides by 3. X is equal to 11. So our first number is 11, and our other number is 2 times 11 plus 3, or 22 plus 3, which is 25. So it's 3 more than twice the first number. So our two numbers are let's rewrite that. Numbers are 11 and 25. Okay, so we were able to write an equation to express those things, solve the equation, and then we wrote it, the solution to the problem, in words. So those are the solutions following the steps for solving a real-world problem. Let's do another example. In this example, we want to find a linear equation to model a real-world application. It costs ABC Electronics Company $2.50 per unit to produce a part used in a popular brand of desktop computers. The company also has monthly operating expenses of $350, which I'll rewrite that 0 so it's clear, for utilities, and $3,300 for salaries. We want a model of the company's monthly expenses. So let's let C be the total monthly expenses let's let X be the number of parts produced, and then the other things we know are the cost of the utilities and the salaries, which are constants. So we've identified the things we know. We spend $2.50 per unit to produce the part, $3.50 for utilities, and $3,300 for salaries. We have assigned variables for the things that we don't know. And we can write an equation in terms of C and X relating one to the other and we'll be able to write an equation to represent these quantities. So the total cost is equal to the cost per unit, which is $2.50, times X, plus the constant values we have, 350 plus 3,300, which we can add together. We get 2.50x. What is 3,300 plus 3,000 or 350? Well, that's just 3,650. So for every part we sell, part we produce, will cost $2.50 to produce, and then the monthly cost of $3,650 will be there every month. So dependent upon the number of parts produced will give us the final value for C, or the cost for monthly expenses. Now again, when we're asked what the company's monthly expenses are, our answer is not a number. Our answer is this equation. So be sure you know what you're being asked for when you do a problem. Let's now consider some formulas. The perimeter, area, and volume of a rectangle, or in a volumetric case, a rectangular box or a rectangular prism. So the perimeter of a rectangle, the perimeter P, is equal to 2 times the length plus 2 times the width. L is length, W is width. In area, the area A is equal to the length times the width, and then the volume V is equal to the length times the width times H, which is the height of the box. So those are some formulas that you'll probably see, and what we'll want to do with those is either plug in values and solve, and evaluate, and sometimes we'll be asked to solve for the length if we're given the perimeter and the width, or the length when we're given the area. The way we do these is just the same as solving a linear equation. You're just trying to isolate a particular variable. We'll do one example of that, and that will conclude this section. Let's solve the perimeter of a rectangle formula for L. Well, remember, P is equal to 2L plus 2W. How do we solve for L? Well, first we subtract 2W from both sides. So P minus 2W is equal to 2L. And then to isolate L, we need to divide both sides by 2. So L is equal to P minus 2W all over 2. And that would be your final answer for finding what the length is for the formula. Now, if I was given P and W, we could evaluate this formula for L. Okay? If you haven't, as always, if you have any questions on your homework, feel free to reach out by email or come by my office hours. This concludes sections 2.2 and 2.3. Good luck on your homework.